Greetings, Yuma High School. Welcome to perpendicular bisectors and angle bisectors. We're going to talk about those in general, and then we're going to spend a couple days after this applying them to triangles again. We're going to be heavy on triangles here for a bit. But first, let's talk about perpendicular bisectors and angle bisectors. All right? And what's especially the relationship between points on a perpendicular bisector and the endpoints of a segment. Okay. Next, what's the relationship between points on an angle bisector and distances from the sides of an angle? All right. Vocab: equidistant, and then we'll define the distance from a point to a line. All right. So here we go. Remember when we took a little time, very start of the year, where we started playing with what we called constructions. You might remember we made what was called, well, we made perpendicular bisectors, basically by setting our compass point on one endpoint of a segment and making a line, and then going back and doing the same thing from the other segment and making an arc. And we said where those two arcs met, if we just connected the dots, go back over here, take a line like this, let's make it green. All right, and if we just connect those places where they cross, and then got rid of our little arcs, what we've done with the green is created a perpendicular bisector. All right, now what we didn't talk about then was that it did not matter, if I undo that, it didn't matter where or how big we made these arcs, okay? All right, as long as we made them the same distance from A and B. So in other words, I could have made arcs that were, let's set this back over there. I could have made arcs that were this big, or this big, or this big, but check it out, it really doesn't matter, because no matter what, all of these points are going to line up perfectly within the intersection of those arcs. What it's telling us, guys, is that what we're actually doing is creating a series of points that is equally distant from both A and B. So we're going to use that relationship that any one of these points, make a little red mark here, any one of these points, whether it be there, or there, or there, there, or any other place based on the size of our arcs, any one of those points is going to be on the perpendicular bisector. And what it really is telling us is that any point that is on a perpendicular bisector of a segment is going to be equally distant from the two endpoints of the segment. In other words, if I pick this point here, the distance from here to here will be the same as here to here. If I pick this point here, distance same from here to B and to A. Let's give you some actual words to go with that. Theorem 5.2 specifically is telling us, it's the perpendicular bisector theorem. If a point is on a perpendicular bisector of a segment, it is equally distant from those two endpoints. So in other words, if P is on the perpendicular bisector of segment AB, then it must be as far from A as it is from B. Make sense? If a point is on a perpendicular bisector of a segment, it is equally distant from the two endpoints. Okay? Converse is also true. Okay? If a point is equally distant from the two endpoints of a segment, it must lie on the perpendicular bisector. All right? Okay. Make sense? Study if you need. Okay, so here's how we use them in problems. All right. So, what is the length of QR? Well, it's fairly obvious, I hope, that what we have here, PS and SR are congruent, so it's so PR is being bisected, plus that's a perpendicular line. Therefore, SQ is a perpendicular bisector, and if SQ is a perpendicular bisector, then Q, point Q, must be equally distant from R as it is from P. Or in other words, this segment must equal that segment. So, here's some explanation, and here's our math. Pause, continuing on when you're ready. All right, here we go. All right, next, important to understand that we need to define the distance between a point and a line, all right? Because here's the thing. When I talk about the distance from a point to a line, am I talking about that distance right there, or that one, or that one, or that one? Okay? We have too many different choices to make as far as how we tell how far a point is from a line. So we make a definition. We say, okay, you know what? Officially, the distance between a point and a line must be the distance of the perpendicular segment between that point and a line. So the distance between a point and a line, or a ray, or a segment, or whatever, is defined to be the length of the perpendicular segment from the point to the line. Now that's important because we're going to go back here and remember another one of our constructions that we did back in the day. We learned how to do this, all right, where we made a little arc. Then we moved our compass point over here, and we made an arc inside here. Did it again over here. And we said, okay, now we can get rid of this. Oops, get rid of this. Oh, can't do that. And draw a line that connects that point through the middle of there. And get rid of these guys. And we've created an angle bisector now. Okay. The way we did that was by basically finding the point that was equally distant from the point that we put on this with our arcs. Then we found a point that was equally distant from here to here. So what that's telling us again is it didn't really matter how big we made our arcs. Okay, using the same technique as we had before, any one of these points is going to go smack dab through our angle bisector marks, okay? What we're saying here is basically an explanation of Theorem 5.4. An angle bisector, if a point's on the bisector of an angle, then it is equally distant from the two sides. Okay, so here point S is on the angle bisector, therefore PS must be congruent to RS. Okay, if a point lies on the perpendicular bisector, it is equally distant from the sides. Not only that, converse is true as well. If a point is equally distant from the two sides of an angle, it must lie on the angle bisector. Okay, so problem here. Go ahead, stop, pause, study. I'm going to begin again. Here we go. I'm going to read along with the explanation. Pause if you need, because I'm moving on. And we'll see you in class tomorrow.